All right, Mr. Ahmed here working on lesson 1.2 for geometry, and this involves the segment addition postulate. A postulate slash axiom, those are kind of words that mean the same thing, and they are rules that are accepted without proof. That means they're very obvious in nature. So we are going to go over the very first one, which is called the segment addition postulate. Before we do so, a couple key notation facts. When we have the segment sign above two letters, that means the actual line segment in the diagram. If I just have those two endpoints listed with no segment above it, that means it's the length, how long it is. So it could be 2 feet, 3 feet, 2 inches, 2 centimeters, all kind of varies. But no segment sign means length. The segment sign above means the actual segment in the diagram. So when I'm starting to write equations, I will use just the notation of listing the two endpoints of that segment. Keep in mind, I cannot write the length of a line. A line has no measurable value because it goes on forever and ever. So hopping into the segment addition postulate. It's very obvious in nature, but essentially, if I look at one entire segment, A to C, that's broken apart into two different pieces or three different pieces, doesn't matter. In this case, it's broken apart into two. I have segment AB and BC. So the entire length of AC would be equal to AB plus BC. So I could add those two parts together. It's listed out in equation format right here. AB plus BC is equal to the entire length, AC. Sometimes I'll say part plus part equals the whole length. So a couple of these questions at first are going to seem very, very easy. I'm going to actually write out the equation using the segment notation just for some practice and making sure that it's clear how it's written. You do not need to write down this equation each time. So the entire length JL is equal to the first part JK plus the other part KL. Like I said, you do not need to write out this notation. You can just find the answer. That's okay. So JL is equal to the first part JK, which is 8.4, plus KL, 3.9. When I add those two pieces together, we will get our solution for the length, which is 12.3, and that's JL, 12.3, and our units were in centimeters. I'm going to include that and circle my answer. If you see the units, include them. The next one, I'm looking for AB. So AB is this piece right here. So that's part of it. So, I mean, obviously, we could look at this and just say 12.2 minus 5.8. I am fine if you do it that way, but I'm going to actually write out the equation so we see where it's coming from. So the entire segment AC is equal to AB plus BC. That's the equation. Whole thing equals the part plus the part. In this case, A to C is equal to 13.2. AB, we do not know. That's what we're finding. BC is 5.8. Then I could solve the equation for AB by subtracting 5.8, and we will get our solution. 13.2 minus 5.8 is 7.4. So AB is equal to 7.4, and we are in meters. Like I said, you do not need to write out this entire equation every time you do a problem. You can just take 13.2 minus 5.8. That's okay. Next one does not have a diagram. So I'm going to want to draw out the picture so it's a little bit easier to see what part's what. So it says if y is between x and z. So that means I have a segment with endpoints x and z. Y is somewhere in between. We don't really know where. Okay, doesn't need to be drawn to scale either. I'm just labeling it out that way. Next step, I know x to z, the entire length. So I'm labeling from x to z is 12. Notice I indicated I went from x to z with my 12. XY is 5, so this part here from x to y is 5. I didn't need to draw that out. If it's the number's just above the segment, I know it's in between those two endpoints. With the 12, I need to indicate where I was going to because that y is in between. We are looking to find yz. So yz would equal 12 minus 5. That's fine if you do it like that. I'm actually going to write out the equation again just for clarity. So the entire segment xz is equal to the two parts xy plus yz. Plug in what we know. Yz, x to z is 12 equals xy, which is 5, plus yz. That is what we are finding. Subtract 5 from both sides, and our solution is 7. So yz is equal to 7, and we do not have a unit, so I'm just going to say 7 units with a little u. You could also write out the word units. That is up to you. Choice is yours. So like I said, if you just want to take 12 minus 5, write down the answer after you've drawn out the picture, that is okay. All right, moving on to the next page. This one has our diagram written out. So in this case, it appears as if our entire segment is 30, and our two parts are 6x minus 5 and 2x plus 3. So the entire segment NM is equal to NL plus LM. I'm not going to write that out this time. I'm just going to set up the equation. So the entire length 30 is equal to the first part, 6x minus 5, plus the other part, 2x plus 3. Now we will solve the equation. Variables are on the same side, so combine like terms. 8x, negative 5 and 3 adds up to negative 2 equals 30. Add our 2 to both sides. 32 equals 8x, and divide by 8. X is equal to 4. We do not need to plug it back in. It just said to find x. 2 left. Next one. This time it says find the value of x. So I have to find x, and I also have to find us. So I have to find two answers. Make sure you read the question before you start answering. We have to have two different solutions. It tells us u to t is 12. So let's locate ut. U to t, 12. So that means 12 is equal to 5x minus 3. Those two values are equal in length, 12 and 5x minus 3. We will then solve. Plus 3, 15 equals 5x. And then we'll divide, and x is equal to 3. So we found x. First part is done. Second value says us. U to s. So we have to find the entire length. For me to find the entire length, I know ut is 12. I need to find ts. Ts would equal 7 times x. X is 3, so 7 times 3 is 21. So the entire segment, u to s, is equal to 12 plus 21. Add those two up, and we get us to equal 33. Notice I labeled what 33 was. It's us, and that is in units. I did not give a unit for the x because x was just solved for a value. X was just equal to 3. So, last one. I'm going to have to draw a picture for this one as well. So, drawing out my diagram. Let's see here. Suppose point O is between M and N. So I know that I have M as an endpoint. I have N as an endpoint, and O is somewhere in between. Doesn't matter where. I'm putting it there. Now we'll label what we know. M to N. Whole thing. Putting that down below. I'm labeling it as 4x plus 10. Mn, 4x plus 10. Next part, M to O. I can just put that there because that segment is just one part. So that's x plus 5. N to O, O to N, same thing. 2x plus 15. So, setting up my equation, the entire length, 4x plus 10, is equal to the two parts added together, x plus 5 plus 2x plus 15. When we're solving these, we're always looking to set up an equation. Something is going to be equal. Set up the equation to solve. Combine our like terms on the right. So 2x is 3x. 5 and 15 adds up to 20. And that's equal to 4x plus 10. I'm going to move the 3x since it's smaller. Subtract 3x from both sides. X plus 10 is equal to 20. And we will then subtract 10. Subtract 10. X is equal to 10. So we found x. Bam. It also tells us to find the length of each segment. So I need to put x back in. So when I put mn, I'm just going to do this part in my head. X is 10. So 4 times 10 is 40 plus 10. That has to equal 50. So mn equals 50. You have to take x and substitute it back in for all three parts. Okay, so MN is 50. MO is equal to 10 plus 5, that's 15. And NO is equal to 2 times 10, that is 20, plus 15, that's 35. It did not give us units, so I'm calling that units, units, and units. That is the end of lesson 1.2. Have a great rest of the day.